Yes, sir.
Yes, sir.
Right. Okay. So now, right. So last class we seen one or two examples are how to form PDE by eliminating the arbitrary constants, right? And I told if the number of arbitrary constants is equals to the number of number of independent variables, then the PDE you are getting should be of order 1. If the number of arbitrary constants is more than the number of independent variable, then the PDE corresponding to the function will be of order more than 1. Will be of order more than 1. Right? So now we see some more examples on that. Right? But some typical examples. Right? So now can you see that that screen? Example number 10. Right? I hope
Yes,
so.
sir.
So it says find a partial differential equation of all spheres of given radius. So what it says, all spheres of given radius. Given radius means radius is a fixed one. So radius doesn't change, but there is no fixedness about the center. So center may change. Center may be any ABCs, right? But radius is also a constant, but it is a fixed one. So now we can write the equation of a sphere. Equation of a sphere with fixed radius. So this R is called fixed constant. And this ABCs are the center of the sphere and they were arbitrary constants because still we know that are numbers, but we don't know what is the number is. It may be 1, 2, 3, it may be 4, 5, 6. So center may be anything. So ABCs are arbitrary constants and R is a fixed constant. So here how many arbitrary constants are there? Can anybody tell? How many arbitrary constants are there in this function? Anybody can tell? How many arbitrary constants? Hmm. How many arbitrary constants? X minus a the whole square plus y minus b the whole square plus z minus c the whole square. How many arbitrary constants? Or you see the screen or not?
Three, sir.
So in the screen itself it is there. How many arbitrary constants? 3. Okay, how many fixed
Three,
constants?
sir. Yes.
How many fixed constants? How many fixed constants? How many fixed constant? Gerald, Mukesh, anybody? How many fixed constant? What is R? Tell me. Somebody has to tell. What is R?
Radius of a sphere.
R is radius, sir.
Yes. Whether it is changing, it is not changing because in the book question itself it is given radius, right? So given radius means it's this a fixed one. So here we have 3 arbitrary constants or 1 fixed constant, that is R, right? So how many independent variables are there? How many independent variables are there in this equation? Independent variables.
Two, sir.
2 independent variables. What are they? What are they? What are the 2 independent variables? X and what are the 2 independent variables? X and
Y.
Y, right? So X and Y are independent variable, right? So X and Y are independent variable, but Z is the dependent variable. Depends on X and Y, right? So this is the thing you have to understand first, right? Hereafter, routine things. What you have to do? You have to do the differentiation. Since here the number of arbitrary constants is more than the number of independent variable, definitely you have to find a PDE of order more than 1, right? So you have to do at least 2 times differentiation. So first time if you differentiate with respect to X of this equation from here to here, so what do you get? you get 2 times x minus a plus 2 times z minus c, and then dou z by dou x, right? So this I think last class itself I explained, right? So when you differentiate z, right, differential of z is dou z by dou x. Then you may ask, sir, here why you are not putting here anything? See, here also we are differentiating x with respect to x. So here, what normally comes no? Here it comes as dou x by dou x. Dou x by dou x. So since dou x by dou x is 1, so that we are not putting anything here. But here 2 times z minus c dou z by dou x. And as far as y minus b is concerned, it is like a constant because you are partially differentiating with respect to x. So it is something like a constant, so it becomes 0. Similarly, r is a constant, so it also becomes 0 here. So now you are getting cancelling 2 and 2 here, cancelling 2 and 2 here. Then you get x minus a, z minus c, and dou z by dou x can be written as dou z by dou x. Can be written as p. Right? So from that you're getting this x minus a plus z minus c times p equals to 0. Now you have to do the same thing with respect to y. So in that case, x minus a becomes 0, y minus b becomes 2 times y minus b, and z minus c is nothing but 2 times z minus c dou z by dou y equals to 0. And then again you cancel 2 and 2, y minus b as it is, z minus c as it is, into q equals to 0. Right? So this is only a first times. Right? But still it is not a PDE because it contains the arbitrary constants a, b, and c. So we can't qualify it as a PDE. Because in a PDE, no arbitrary constant should be there. All arbitrary constants should be eliminated. So that what we have to do now, again you have to differentiate what we have differentiated already. So here we take once again this equation, that is equation number 2, and again we are differentiating with respect to x. Then differential of x is 1, a becomes 0, and then z minus c into p. Here only we have to be very careful. This is z minus c into p, right? We already know z is a function of x and y, and similarly p, that is dou z by dou x, is also a function of x and y, right? So now we have to use the simple idea, that is uv rule, right? So what is d of uv? What is d of uv? Anybody can tell? D of uv is uv dash plus vu dash. Right? So what we have to do? First we have to z minus c as it is, that is u. You take this as u and take this as v. Sorry. Take this as u and this as v. Right? So u is z minus c, v is v dash. V dash means differentiating p with respect to x, that is dou p by dou x. And then vu dash. V means that is p, so v is that is p, and then u dash. What is u? Z minus c. So if you differentiate z minus c with respect to x, you will get dou z by dou x. Dou z by dou x. So here the use uv dash plus vu dash idea. uv dash plus vu dash idea. Right? Now again you should be very careful. Dou p by dou x. What is p? P is nothing but the first derivative. P is nothing but the first derivative. So if you differentiate p with respect to x, since p is dou z by dou x, since p is dou z by dou x, so differentiating this again with respect to x means, differentiating this again with respect to x means, it become dou square z by dou x square. So dou p by dou x can become dou square z by dou x square, and then here 1p comes as it is. 1p comes as it is. And why it is become p square? Because dou z by dou x is again it is p. So this is P into P become P square. So now 1 plus Z minus C. And now what is dou square Z by dou x square? We have a standard notation for dou square Z by dou x square. That is R plus P square equals to 0. Plus P square equals to 0. And finally we can write Z minus C into R equals to 1 minus P square. Taking this 1 and P square on the other side. So it becomes minus of 1 plus P square. Minus of 1 plus P square. Right? So you just go through this. So I give 1 minute time. I just, right, keep the thing as it is. Right? 1 minute time, you just see this. Only 1 minute. Just go through it. If you have any doubt, ask me, because this is very, very important. Can we move on? Tell me. Can we move on? Sumit, Gerald. Can we move on? Do you have any doubt on this?
No, sir, no doubt.
Okay. Now, whatever we did with respect to x, the same thing we have to do it with respect to y. So again, take the original function. What is the original function? Original function is this. X square, x minus a the whole square, plus y minus b the whole square, plus z minus c the whole square equals to r square. Right? So again, differentiating the original function with respect to y. Right? Wait. So that only comes here. So again, 1 plus z minus c. Instead of dp by dx, it is dq by dy. Then in place of p, q is there. In place of x, y is there. So there is only one change. Wherever p comes, q will come. So when you differentiate with respect to y, what is the only change? Everything is ditto as it is. Only thing is, in place of p, q will come. In place of x, y will come. Apart from that, both are similar. Both are similar. If you see, compare equation 4 and 5. If you compare equation 4 and 5, you see both are same. Right? Only in place of p, q will come. And what is r and t? R and t are nothing but second derivative with respect to x, that is r, and t is second derivative with respect to y. Right? Apart from everything is ditto. Right? See, this is dou square z by dou x square. This is dou square z by dou y square. Only thing, in place of x, y will come. In place of p, q will come. Right? So now, after doing this type of differentiation twice, we get two equations. One is z minus c times r equals to 1 minus p square. That is the first one. And then z minus c times t equals to 1 minus q square. That is the second one. Now, very simple. Right? So take z minus c on one side, take r on the other side. So it becomes divided by r. And this become divided by t. Right? So z minus c, z minus c. So if LHS are equal, RHS also should be equal. From that only they get this. From that only they get this. Otherwise, this is called as cross multiplication, because this equal to this and this are same. So LHS equal to RHS. So they put the cross multiplication and they get r by t equals to 1 plus p square by 1 by q square. Otherwise, you can do one thing. You can divide 4 by 5. Divide 4 by 5. Right? Then automatically z minus c will cancel out. R by t will be there. Minus, and this minus will cancel out. Then 1 plus p square by 1 by p square automatically there. Right? Very simple. Instead of doing all this, you simply divide equation 4 and 5. You will get a relation like this. And in this relation, we have only derivatives. P and Q are first order derivatives, R and T are second order derivatives, and there is no arbitrary constants are there. So this is a second order PDE corresponding to your original function, that is x minus a the whole square plus y minus b the whole square plus z minus c the whole square equals to r square. Right? So in this manner, you can form PDE for lots of functions. functions. There are certain functions they give straight away like this, or certain functions they don't give the function in the question, they give only the words. By understanding the words, you can see what is the original equation. See, in the question they give only find a partial differential equation of all spheres of given radius. So equation not given. So by understanding this line, you have to write this. That is very, very important, right? If you don't know how to write this, then you can't start the problem. So you should understand the question and you have to write form the equation. Then after forming the equation, you can form the corresponding PDEs. Corresponding PDEs by partially differentiating with respect to x and y. Right. So are you able to understand? Because now I move on to the next section. Are you able to understand how to form PDE by eliminating arbitrary constants? Can we move on to the next section?
Yes, sir.
Right, okay.
Yes, sir. Right. Okay.
Right. So next thing is formation of PDE by eliminating arbitrary function. By eliminating arbitrary function in the original equation. Right. Now you can see here. Eliminating the arbitrary function f from the equation z equals to f times x square plus y square. What is this means? What does this mean? If it is simply x square plus y square means we know that is an equation. What is the meaning of z equals to some function of x square plus y square? Anybody knows what is the meaning of this? Why they write f of x square plus y square? What does it means? Do you know? Anybody knows? Z equals to, if they write simply x square y square, then okay. Why if they write a function of x square plus y square means, what is the meaning of this? Anybody knows? Anybody at this try? What will be the why they are writing like this? If they write like this, what it means? Anybody knows? Okay, no reply. See, if they tell some function of x square plus y square means, here you can write right hand side, you can say any function, but it contains x square y square. So if I simply write x square plus y square, then also it's okay, good. So I write function of x square plus y square is simply x square plus y square. Something like writing f of x equals to x. Right? You know, if I write f of x equals to x, what it means? Function of x is x itself. The same way I can write f of x square plus y square equals to simply x square plus y square. In that case, z equals to x square plus y square. Otherwise, I can write sine of x square plus y square. Function of the function may be anything. It may be a constant function, or it may be a sine function, or it may be a cosine function, or it may be a log function, whatever it may be, but it contains the argument x square plus y square. So in that case, z equals to sine x square plus y square, or it may be z equals to cos x square plus y square, or it's z equals to x square plus y square the whole square, or z equals to log of x square plus y square. So it may be in any format. So this right hand side has an arbitrary function. So the right hand side is a function of x and y, but it is not fixed. It will keep on change. It will keep on change. It may be sine of x square plus y square. It may be cos of x square plus y square. So here arbitrariness is not in the constant. There is arbitrariness in the function itself, right? So in this equation there is no arbitrary constant, but it has an arbitrary function. Now, if you want to find a PDE corresponding to this function or this equation, definitely we have to remove this f, right? We definitely have to remove this f. But how to remove it, right? How to form the PDE, that only here we are going to discuss, right? But it's very simple only, no problem. So, what is the original function given? Z equals to f of x square plus y square. So if you differentiate one time, it is dou z by dou x. So if you differentiate it, it become f dash times x square plus y square. Then if you differentiate once again, right, this component, then it become 2x. Then it become 2x. Similarly, right? If you differentiate this component with respect to y, it becomes dou z by dou y. Differential of f is f dash of x square plus y square. Then whatever the things inside, that you have to differentiate it. Then it becomes 2y. So x square plus y square become 2y, right? So in that case, you have two relations. One is p equals to f dash of 2x. Another one is that is q equals to, this is another thing, right? One is p equals to f dash of 2x. Another one is, this is q, right? Q equals to f dash of 2y. F dash of 2y. So we have these two equations, right? So here 2x, here 2y. Only thing, so see, as I told already, wherever p is there, that is replaced by q. Wherever x is there, that is replaced by y. The common things as it is. The common things as it is, right? So from these two equation, right, you can equate it these two things, or you can find a division of this. Then you can cancel this out. Then you get p by 2x equals to q by 2y. From that you will get an equation py equals to qx. Py equals to qx, right? Py equals to qx, right? So I stop my screen. I just, right, take the right. Are you able to see your roll call?
Yes, sir.
Right? Okay, wait.
Yes, sir.
Okay. So now we'll take the attendance, right? Answer attendance properly. Right. Anit,
Present, sir.
present. Okay. Kokala Kannan, absent. Pradesh, absent. Regapoth, Jonathan.
Present, sir. Present, sir.
Sunil, yes.
Present, sir.
Syed Sagid, Syed, absent. Hari Govind, absent. Mukesh, yes. Mukesh, yes, absent. Mirza Sadiq, Aman Kumar, Aman Kumar present. Kumar Yuvaraj,
Present, sir.
Kumar Yuvaraj,
Present, sir.
present. Anand Kumar,
Present, sir.
Smith Kumar,
Present, sir.
Ved Prakash Kumar, Ajit Kumar, Arun Kumar Ram, Satyam Kumar, Raj Kumar Mandal, Vijay Kumar, Dhanush, Harish, Manipandian, Dhanush T, Vijay Praveen, Mukesh C.
Present, sir.
Present, sir.
What's your
Vijay
name?
Praveen.
You tell
Mukesh
your name.
C.
Mukesh
Mukesh
C.
C.
Ah,
Present.
then
Vijay.
Gerald. Who is the other person? Mukesh C present. Then who is the other person? Gerald, are you present? Surya B.
Yes, sir.
Surya
Present, sir.
B. Surya
Yes,
B
sir.
present. Mohammad Rizwan. Yes, Surya. Sri Arasu. Sriram. Edwin Raj. Ahmad. So present is are Anit, Jonathan, Sunil, yes, Aman Kumar, Kumar Rivaraj, Anand Kumar, Smith Kumar, Mukesh C and Surya B.
Sir, Vijay is present. I think he has some problem. Mic problem.
Sir, Vijay present, sir. Present.
Vijay Praveen.
Yes,
Huh?
sir. Yes, sir.
Okay.
Okay, sir.
Is there anybody name is left out here? All of you gave your attendance? Okay. Right. So this is the attendance I finalized today. The same people has to give, whoever say present now, has to give their out attendance at the end of the class. That is very, very important. Otherwise, attendance will be given. Right? So all of you, right, must give the out attendance at the end of the class. At the end of the class.
Sir,
Ah,
Gerald SS present, sir. Putting on messaging, sir.
Gerald is present.
Yes.
But where is Gerald is? Tell me.
I think mic problem, sir.
But he has to reply no.
Putting on messaging, sir, in chat box.
But that type of things I don't want. He's putting message is not one. If I ask yes or no, he said yes or no. If it is any mic problem, he has to tell. Okay, now only it is tell network issue. Whether it network issue means now your network is okay, Gerald. Just typing is working means network is not issue. Maybe it's mic issue. The problem is if mic issue or audio issue means then how can you follow the class? See, the class is not simply on switch on the video or switch on the Google Meet and typing only, not like that. You have to follow my class, right? So since you say some network issue, Gerald, I give. Okay, you can hear me. Okay, right. See, if you have any network issues like this, but if you are not able to communicate, when I start the class itself, you join 5 minutes before and you type, this is my problem today, so I can able to hear, but I can't tell. That you have to tell in the beginning itself, so that when I take attendance, I will mark it present. Okay, right? Because I need proper explanation from the students. I can't simply see the screen and can't simply put present absent. Right? Okay. Right. So now we move on to the our class. Right? Okay. So this is the way you can eliminate a arbitrary function, and you can find a relation like this: py equals to qx, and this is also a PDE containing the partial derivatives p and q. But here the one important thing you have to understand: whenever an equation containing only one arbitrary function, the resulting PDE is of order 1. But there are some equations which contains more than one arbitrary function. There, the resulting PDE is of order more than 1. Is of order more than 1. Right? We will see some more examples on this. Right? But remember, for all these things, what you need is you should know basic differentiation and differentiation methods, that UV method, U by V method, and you should know the basic substitutions. All these things you should know. Then only you can do. Right? So now we move on to example 12, that is eliminating the arbitrary function f from the equation z equals to f of xy by z. So what is this? This a function may be of the form xy by z, or it may be of the form sine of xy by z or cos of xy by z. So it may be in any form, so that generally they simply put some arbitrary function f. So it may be in any form like this, so that they put the arbitrary function f in place of sine or cos, all this. Right. Now you have to eliminate this in order to form the PDE. Again, same thing, you have to differentiate z with respect to x, it becomes dou z by dou x, then that becomes p. Right? And now here only you have to be very, very careful. Differentiation of f is f dash. And whatever inside this thing, you have to differentiate. But now it is x is a function of x and z is also a function of x. So the numerator is also a function of x and denominator is also a function of x. So you have to use the U by V rule. So what is U by V rule? U by V rule is V U dash minus U V dash divided by V square. This is U by V rule, right? So here that xy you take it as U and z you have to take it as V. xy you take it as U and z you have to take it as V. So here V is z as it is. U dash means x into y. But you are differentiating with respect to x. So y is something like a constant. So x into y, if you differentiate, differential of x is 1, y is a constant. So y comes as it is. So this is y, how it comes differentiating xy with respect to x, then y comes as it is. Minus u. What is u? U is xy. So xy as it is into v dash. V dash means what is v? V is z. V dash means dou z by dou x. V dash means dou z by, that is differentiating z with respect to x. So that only they put here, divided by v square. What is v? V is z. So v square means z square. Right? So this type of, I think, simple things only, but you should know, you should remember, right? Okay. So now dou z by dou x can be written as p. Here also dou z by dou x can be written as p. Right? So from that we can write f dash of xy by z equals to taking these terms on the other side by simply the cross multiplication p z square, and this comes this side. So this is for x. Now we can write the same thing for y. But I also, as I told already, what is the only change you will get? Wherever p is there, q will come. Wherever x is there, y will come. That is the only change. So now just see here dou z by dou x. You just see dou z by dou x. So when you differentiate with respect to y, it becomes dou z by dou y. F dash x y z as it is, no problem. Z as it is. In place of y, x will come. Xy substitution as it is. In place of dou z by dou x, here dou z by dou y will come. So that is the only change. Wherever p is there, that is dou z by dou x, that becomes q. Wherever x is there, that becomes y. So now by simplifying this equation, they get this one, q z square by zx minus xyq equal to f dash of xyz, right? So now one thing is very clear. This equation, that is equation number 3, as well as the equation number 2, both are, this equation number 2, both are equivalent to the function f dash of xy by z. So f dash of xy by z equals to pz square. At the same time, f dash of xyz equals to qz square. So left hand side is equals to right hand side. So we compare both the left hand side. We compare both the left hand side, and then we get pz square by zx zy minus xyp is same as qz square by zx minus xyp, right? And hereafter we do simple cross multiplication from here to there and do some simplification, and finally we will get this nice equation px equals to qy. So again it is a first order PDE corresponding to the original function, where the original function is of the form z equals to f of xy by z. So since the original equation contains one arbitrary function, we can associate that with the first order PDE, which is of the form px equals to qy. That is dou z by dou x into x is equals to dou z by dou y into y. Right? So this is for functions having only one arbitrary equations containing only one arbitrary function. Right? So now we will see the same thing for more than one arbitrary function. That is more than one arbitrary functions. There are some typical methods are there, right? You can see so many problems are there. This is another way of solving the problem, right? Okay. So now I will give you an example. This is a little bit different from what we have seen previously, right? So previously all the equations of the form z equals to z is left hand side, and the right hand side it may be arbitrary constants or some arbitrary functions, right? So arbitrary constant may be 2 or 3 arbitrary constant, But arbitrary function, so far we've seen only one arbitrary function, that is of the form z equals to f of x square plus y square, or z equals to f of xy by z, right? But now here you can see a function. Find the form of PDE by eliminating the arbitrary function phi. So they themselves mention phi is an arbitrary function. But here the function is given in this form. It is of the form some function of z square minus xy with x of z. See, this is also a typical one. So here arbitrary function is only one function. So phi is only arbitrary, but it has two what can I say, terms or two variables, right? It is something like writing f of x comma y, writing f of x comma y. So what did I say? F is a function where x and y are arbitrary variables, where x and y are variables. Similarly, phi is an arbitrary function, but it has two ordinates. We call it as ordinates. It has two ordinates. One is z square minus y, another one is x comma z. So what this type of functions look like? What this type of function look like? It may be of the form z square minus xy plus x by z equals to 0. Simply adding two functions, adding two terms, you will get one equation. It may be like this. Or it may be like z square minus xy, the whole square. It may be square, and this is sine of x by z. Right? So arbitrary function is only one arbitrary function, but it has two ordinates. That both ordinates may take any form, right? So there are some this type of functions also there. For this type of functions also, you can associate this type of functions with a PDE, But here the working procedure is little bit different because if it starts from z equals to something, means you directly substitute with the differentiate with respect to x and with respect to y, and then you can finish it off. But here it is not at all in the equation form. It is only in the ordinate form. Phi of u comma v. U is one function. It is not plus. This is two ordinates. So directly you can't differentiate the ordinates. Directly you can't simply write 2z minus x comma. That type of thing is not there. The function should be in the functional form. Then only you can differentiate it. If it is in the ordinate form, that is, if it is in the point form, x comma y, right? X into y you can differentiate, right? X plus y you can differentiate, but x comma y you can't differentiate, right? So in that case, there's a separate idea is there, and workout procedure is there. But what you have to remember is very simple. Because going the theory of all these things will confuse you. So what you have to do, that only I will tell. You just go through, follow it, then automatically you will get the answer, right? So whenever the equations of the form like this, some function of u comma v equals to 0, you just name the first ordinate as whatever it may be. You name it as u, and you name the second ordinate as v, right? If you form a PDE for this equation, it should be of the form, right? Standard form. It has a standard form. It is of the form capital P into small p. Small p is nothing but dou z by dou x plus capital Q into small q. So capital Q is some function of x and y, but small q is dou z by dou y, and capital R. So what are this capital Q, capital P, capital Q, and capital R? That is only given in here. The capital P and capital Q and capital R are nothing but the derivatives of u and v with respect to yz, with respect to zx, with respect to xy. But how to find this? What is the notation of this? This is called the Jacobian of the function, right? So if you want to find p, this term can be written as modulus. This is the determinant of, otherwise you call it as modulus, but this you can as determinant of dou u by dou y, and then dou u by dou z, then dou v by dou y. In the second row, it is dou v by dou y and dou v by dou z, right? So p can be written as like this. The same thing can be written in terms of determinant form like this. So dou u by dou y, dou u by dou z, dou v by dou y, dou v by dou z. But how to find this? Very simple, because you already defined what is u, what is v. You simply find dou u by dou x, dou u by dou y, and dou v by dou x and dou v by dou y. So it's very simple. So u is z square minus x square. So if you find dou u by dou x, right? So dou u by dou x means differentiating u with respect to x alone, right? With respect to x alone. So x alone means here, remember, u is a function of x, y, z, v is a function of x, y, z. So here x, y, z having treated in a common, can be treated in a similar manner, right? So here don't confuse z is a function of x, y, and y, not like that, right? So here u is and v are functions of x, y, z. So dou u by dou x, if you find dou u by dou x means it should be only x is considered as the variable, all other things should be considered as constants for u. So dou u by dou x is, this becomes 0, this is minus x, where x is 1, and this is y as it is. So 1 into y is y. So dou u by dou x is y. Similarly, dou u by dou y. Dou u by dou y also simply minus x. And then dou u by dou z. Dou u by dou z is 2z. Dou u by dou z is 2z, right? Differentiating u with respect to z. Similarly, v is there, that is x by z. Dou v by dou x means x, differential of x is 1, 1 by z. Dou v by dou y, there is no y is there, so it becomes 0. Dou v by dou z means x is as it is. You have to differentiate 1 by z. Differential of 1 by z is, differentiation of 1 by z is minus 1 by z square. Minus 1 by z square. So that here they put x into, x comes from here, and differential of 1 by z is minus 1 by z square, so x by z square they put. Right? So if you know these 6 terms, dou v by dou x, dou v by dou y, dou v by dou z, dou v by dou x, dou v by dou y, and dou v by dou z, right? You can able to find all this capital P and capital Q and capital R using this method, right? So you just muck up this method, right? Or that determinant. P means u with y and z. U with y and z, and v with y and z. Q means u with z and x, and v with z and x. So here in P there is no x, only with y and z. In Q, differentiation only with respect to zx. Now there is no y. In R, there is no differentiation with respect to z. It's only with x and y. So you just remember this, and then using this 6 terms, 1, 2, 3, 4, 5, 6, the same 6 terms, you have to substitute here, you have to substitute here, and you have to substitute here also. Then you will get a determinant like this. Then you know how to find the determinant. This into this minus this into this. So this into this is x square by z square minus 2z into 0, that is 0. So x square minus z minus 0. So it is simply like this. Then if you multiply this and this, 2z into z means 2, because z cancel. So 2 minus this into this. This into this is xy by z square. And finally, this into this is 0 minus this into this is minus of x by z. So it becomes plus x by z, right? So by finding the determinant of this, you can able to find all these 3 values, that is capital P, capital Q, and capital R. Now what you have to do, very simple, because you already know this is the associated PDE. So in the associated PDE, we need P value and Q value and R value. So once you find P value, Q value, R value, you simply substitute that, right? Your capital P value into small p, then capital Q value into small q equals to capital R value. So this is capital P value into small p, capital Q value into small q, and capital R value. Straight away you can put, that is your solution. That is your solution. Here there is no differentiation, there is no substitution, all these things. Only thing you have to find these simple things: dou u by dou x, dou u by dou y, dou u by dou z, and dou u by dou x, dou u by dou y, dou u by dou z. Then you have to substitute that in all these 3 determinants or determinants, and finding the determinant value. And what are the values you are getting? All the 3 determinants, 1, 2, and 3. You directly substitute here, then automatically you will get the solution. Automatically you will get the solution. So this way, so here it is not of the form z equals to some function of x. It is one arbitrary function is there that contains more than one arguments. That is contains more than one arguments, right? Z square minus xy is one ordinate, and then x by z is another ordinate. So that they use the idea, right? U equals to z square minus xy and v equals to x by z, where u and v are two functions of x, y, and z. And then this method, right? You no need to confuse yourself, because in this book itself the explanation is there, right? In this book itself the explanation is there. So this is the explanation how you are getting, but I think the explanation you don't want, because at your level whatever you are seeing is explanation of this simple problem. Why, how you write this p equals to q equal to r equal like this. Further explanation is there. So if you have time, you can see this explanation in the book, right? But in examination point of view, right, they ask only problems. So if you solve this problem, then you can easily get the marks. You can easily get the marks. The same way, another problem is also there: x square plus y square plus z square. That you take it as u, x y z. That you take it as v. So this is u, this is v. Again, same this. So again, what you have to do, you have to find dou u by dou x, dou u by dou y, dou u by dou z. So automatically it is 2x, 2y, 2z. And here for xyz, if you find dou u by dou x, it becomes yz, dou v by dou y, xz, dou v by dou z, xy. And then again the same thing. P means there is no x, q means there is no y, r means there is no z. Same thing you can substitute here, then do the cross multiplication, and you will get a nice equation. And what are the nice things you are getting for p, q, and r, right? That you can substitute here, right? That you can substitute here. So this is where capital P from here. This is where capital Q from here, and this is where capital R. P, Q equals to R. Right? 2 is common, so you cancel out. So you will get a nice equation. So in this nice equation, you can see there is no arbitrary function, there is no arbitrary constant. There is no phi is here, right? There is no arbitrary constant, there is no arbitrary function, there is no ordinate also. It is an equation containing the partial derivatives P and Q, right? So all these things having only one arbitrary function, so it all having only one, that is first order PDE. So now we will see in this section a final example there the arbitrary function itself more than one. It is of the form like this: z equals to some function of x and y and some function of g and y, right? So here z is the independent variable, f and g are arbitrary functions. So there are more than one arbitrary function. So when we try to find solution for this, right, the solution will be of the form PDE of the form order more than one. So definitely terms like this, that is R, S, T will come in the final PDE, right? So far that PP plus QQ equals to capital R, capital P, capital Q or capital R functions of X, Y, Z only. That small p and small q are only present so far when the equation having only one arbitrary function. But if the equation having more than one arbitrary function like this, the formation of PDE by eliminating two arbitrary functions x and y, then definitely, right, you will come across RST. That means you have to differentiate more than once here, right? So we'll see this simple example. Only simple example they will ask in the problem in the exam. So what are the examples here I am discussing, or already they asked several times in the university examination itself, right? So all are important examples. I'm not simply taking randomly problems. So what are the problems important to you, both understanding the concept as well as examination point of view, that only I selected and I can give, right? If possible, I can share some more problems as an assignment in the Google Classroom maybe tomorrow, right, for so that you can work it out in your home. But unfortunately, what are the recorded video for the last class is not processed properly, so there's some technical issues there, so that I can't able to put that video in the Google Classroom. But anyway, today's video definitely I will put, right? Okay, so this is the final example we'll see today. So this example says form a PDE by eliminating arbitrary functions f and g. So function of y and function of g, right? So what the function looks like, it may be of the form like this: x square, some function of y, some function of y, it may be some log y, x square log y plus y square, right? So y square as it is. Similarly, this is x square as it is. Gx may be e power x. So it may be of the form like this. But one thing is that this function need not be same. It may be same sometimes, but need not be same. It may be log, it may be exponential, it may be sine, it may be cosine. And moreover, this is having the ordinate y and this having the ordinate x. So that is, it has a variable y, it has a variable x. So this are two typical functions. So both are entirely different arbitrary functions and both takes different notations, right? So now how to do it? So again, you have to do the same thing. So this is printing mistake. This is small p only, not capital P. This is small p only. Right? So this is a printing mistake. Small p only. Dou z by dou x. So if differentiate x squared become 2x, right? And since we are differentiating with respect to x, y is a constant. So function of y is also like a constant. And y square as it is, if you differentiate g of x, it's an arbitrary function with respect to x, then it becomes g dash of x. Become g dash of x, and whatever inside is x, since we are differentiating with respect to x, x by x, that is dou x by dou x is 1, so that we are not putting anything in the right hand side. Right? So it is 1, so g dash of x into 1, g dash of x. This is okay. Now again, we have to differentiate the same thing with respect to q, so with respect to y. In that case, what happened? P becomes Q. That is the only change. X square is something like a constant, so it is as it is, right? F of y becomes f dash of y. I can use blue, right? It is something like a constant, and f of y becomes f dash of y. And since you are differentiating with this to y, y square becomes 2y, and g of x like a constant, so it is as it is. So it is, sorry. Right? So it is as it is. But now whatever we are getting here is not a final one. Why? Because still we have f and g. F dash and g dash are all arbitrary things. So again we have to differentiate once again. So now this is small p, right? So we are differentiating again 2 with respect to x again. Then p becomes r, and here 2, if you differentiate x, it becomes 1, 1. F of y as it is, y square as it is, because we are differentiating with respect to x, only g dash become g double dash. So x becomes 1, g double dash becomes g double dash. That is one thing happened when we differentiate 2. That is differentiating equation 2 again with respect to x. Similarly, differentiating this equation number 3 again with respect to right, with respect to y. Before that, I will do one more thing, right? So this you take. Here they do one more thing. What they do now? So here this is dou square z by dou x square. That is differentiating p with respect to x. And here this is s. S means dou square z by dou x dou y. What is the meaning is, what are you differentiated already with respect to x, that again you differentiate with respect to y. So this is 2 times differentiation x. But here, first you differentiate with respect to x, another time you can differentiate with respect to y. Right? Then what will happen? So here, if you see the order, so dy is first and dx is next. So already dy is there, so that is first. So whatever you already differentiated with respect to y, that you are differentiating now with respect to x. Right? So listen carefully. Right? Whatever you already differentiated with respect to y, that you have to differentiate with respect to x, so that it is dou x dou y. So dou y first, then whatever with respect to y, again you do it with dou x. So now what will happen? You have to differentiate this equation number 3 with respect to x, Then what will happen? Dou z by dou y becomes dou square z by dou x by dou y. That is denoted by letter S. Differential of this with respect to x means x square become 2x. F dash of y is a function of y, so it's like a constant as it is. And 2y is also a constant because you are differentiating with respect to x. And g becomes d dash. G becomes g dash. So you have to be very careful. So this is 2 times x, this is 1 time y, other time x. Now 2 times y. 2 times y means dou y by dou y square. Dou y square means 2 times differentiate with respect to y. So we already differentiated 1 time. Now again we differentiate that thing with respect to y again. So what will happen? This becomes dou square z by dou x square. That becomes t, and x square is as it is because you are differentiating with respect to y. And f dash becomes f double dash 2 as it is. Differential of y is 1, so this 2 into 1. G is also as it is because it is a function of x. So now we have 5 relations. What are the 5 relations? 1, 2, 3, 4, 5 relations we have, right? From these 5 relations, right, we can multiply x with equation number 2 and y with equation number 3, right? So these are simple simplifications. So multiply x with equation number 2 and y with equation number 3, then it becomes px plus qy, and here this becomes 2x square. This becomes like this, 2x square fy plus y square xgx, right? So what you have to do now, you have to multiply p with, you have to multiply x with this equation, and then y with equation number 3, that only they are putting here. 2 into x means equation 2 with x, equation 3 with y, then adding this 2, you will get some relation. You will get some relation, right? Once you get the relation, right? So if you add this multiplying and then if you add this to relation, you will get some relation like this. Then after getting this relation, they see here px plus qy as it is, right? X square plus y square by g square is check, right? This is there, x square plus y square by g square, it is there. What is that? That is equals to z. So that is there here. So this term can be written as z, and then xy into ygx plus xf dash. So ygx plus xf dash, how you get this, right? Ygx plus xf dash is we are getting from equation 5. So this second term is looks like equation 5. Looks like equation 5, and this term is looks like the original equation. So in place of this you can put z. In place of this you can put the equation 5. What is the equation 5? Equation 5 is s by 2 will come, because why they put s by 2? Because here 2x f dash, but here only x f dash is there. Then here 2 yg dash, but here only yg dash is there. So this 2 comes this side. So x f dash plus yg dash can be written as s by 2, and x square f of n g square y square g of x can be written as z. So now we can write it as p of px plus qy equals to z times plus xy into s by 2. Xy into x by 2. That is the final one. Px plus qy equals to 2z plus xy into s by 2. So this is one typical problem. See, here we don't know how we are getting that relation. So that I am telling right from the beginning, there is no standard procedure is there. Here you have to use your common sense and your understanding about basic differentiation and differentiation methods. So this is, so no way this is right. This is only a common sense, right? Okay, if you multiply it like this, then we'll get the equation like this, right? You may ask, sir, why they multiplied 2 with x and 3 with equation 2 with x and 3 with y? Only common sense. Only common sense, because they need to separate this x square y square term, and they need to separate y dash f dash term. That can be only happen if you multiply x with 1 and y with this, and then you can add. And after this, okay, because you already have these relations, try to understand these two relations you are not at all used here. You may ask, then why we find? No problem, right? That you have to find, because in the beginning you don't know which will be useful to you, right? So R and T we are not at all using, but the notation S is used, because when we find this, when we add these two equations after multiplying with x and y, right, we'll get nicely these two things, and this is equivalent to z, and this is equivalent to this equation, that is equation 5. That is nothing but S by 2. Right? Then I can write simply S by, right? So from that they get relation S by 2, and then you take this 2 on the other side and do simplification. Finally you get an equation like this. So in this equation it contains PQS, right? There is no arbitrary function, there is no arbitrary constant, but remember this word, yes, this is very very important, right? Since S is present, it is of order more than 1, because what is S? S is a second order PDE, second order derivative. So whatever the equation you are getting, it is a second order PDE, because P and Q are only first order derivatives. So that XY, yes, this is very very important, right? So from this we can understand, we can able to form a PDE of more than, or of order more than 1, because definitely, because the number of arbitrary functions is more than 1. So the PDE which we are finding in final is also of order more than 1, right? So there are some classical examples are there for this. So I'll give share some problems from 4 or 5 problems. What are the topics we have discussed so far in last 2 or 3 classes, right?